right, we're going to go ahead and do this extension out of Chapter 6. It's called Using Piecewise Functions. And piecewise functions look a little bit different. So here you go. Go ahead and fill in this blank. A piecewise function is defined by at least two equations. So at least two equations, each of which applies to a different part of the function's domain. Remember, the domain values are the inputs or the x's. And here's an example right here. We have y equals x plus 1 if the x values are less than 0. So if the domain is less than 0, then you use this function. And y equals 2x minus 1 if x is greater than or equal to 0. So less than 0 here, greater than or equal to 0, we use 2x minus 1. So here it says the expression, what we're going to end up doing down here is actually graphing it. So I'm going to graph the equation y equals x plus 1 for x's less than 0. You are going to want to use not a calculator, but a pencil for this because we are going to have some erasing to do. I'm going to first just graph the line x plus 1, y equals x plus 1. So here's my 1, and then I'm really looking at x is less than 0, so I don't really want to go this way because here x is 1. So I'll go this direction. And here it is, and it says if x is less than 0. Remember, when we're graphing these, if it's less than 0, then my 0, actually, I don't need this because that's greater than 0. And if it's less than, it doesn't show ownership. So here I really need to put an open circle, and it is array going down because it's less than 0. Now I'll go ahead and I'll graph the other part. Y equals 2x minus 1 if x is greater than or equal to 0. So 2x minus 1, here's my y-intercept, and it's 2x, so up 2 over 1, up 2 over 1. And I want it to be greater than or equal to 0. And since it's greater than or equal to 0, at 0, I can go ahead and use my y-intercept and close the circle. And here is this particular line. So this is what a piecewise function will look like. It comes in pieces. Let's go ahead and go on. So here I have one that's in 3 different pieces. I have y equals negative x minus 1 if x is less than or equal to negative 1. Y just equals 3 if x is between negative 1 and 2. And y equals 2x minus 5 if x is greater than or equal to 2. So I'll take this a piece at a time. So first I'm going to look at y equals negative x minus 1. And here's my equation. Negative x minus 1 will look like this when I graph it out. But they're saying if x is less than or equal to negative 1. Negative 1 is right here. Less than would be all this right here. And it's less than or equal to, so I can go ahead and make it a closed circle there. Whoops. Not super nice. Let me go ahead and grab my tool so it looks a little bit better. And it's going to look like this. And now, I said before, you're going to want your eraser. So I'm going to erase these points because I'm only interested in this portion when x is less than or equal to negative 1, which is occurring right here. Okay, y equals 3, which is a horizontal line, if x is between negative 1 and 2. So here's x, my horizontal line at 3, if it's between negative 1 and positive 2. So I just draw my horizontal line right here. And I have an open circle on each of these because it doesn't include the equality. And finally, y equals 2x minus 5 if x is greater than or equal to 2. But I'm still going to start graphing the whole thing. So here's my negative 5. My slope is 2, so up 2 over 1, up 2 over 1. Here's really where I want to start now because I'm interested when x is greater than or equal to 2. So up 2 over 1, up 2 over 1. And again, I'm starting here. And I'm only interested in x values that are greater than or equal to 2. So I'll go back and erase those. That is what this piecewise function looks like. It's kind of interesting. All right, they're asking us here to figure out what the piecewise function is. So I know it's going to be y equals, and then I have my brackets, and I'm just going to go left to right. I'm looking at this line right here first. And I need to go ahead and figure out the slope and y-intercept of this line. I can see that if I just pick these 2 points, my slope is 1. So y equals 1x plus, I can extend it. It looks like the y-intercept is going to be 3. So y equals x plus 3. If x is, this is equal to, x right here is negative 1, and it looks like it's if x is less than or equal to negative 1. So that's this portion. Now I need this portion. Y equals, my slope here is a negative 1. I can just tell by looking at these 2 points. So negative x, my y-intercept nicely, 1, 2, 3, minus 3. If x is, it looks like it's greater than negative 1, because here it's negative 1, but it's not equal to it because it's an open circle. Here it's 0, here x is 1, so if it's greater than negative 1. There's that piecewise function. All right, so let's go ahead and look at this. I'm going to go from left to right. So y equals, I've got 3 different equations here. This one is a horizontal line, and it's going through positive 1. So y equals 1 if x is, it's less than negative 1. And it doesn't show equality because at negative 1 it has an open circle. Now let's do this one. This one has a slope of rise 2, run 1, so it's a slope of 2, so 2x. The y-intercept appears to be 0, so it's just plain old 2x. If, now the x is between negative 1 and 0. Here it's negative 1, here the x is 0, and they're both closed circles. So negative 1 is less than or equal to x is less than or equal to 0. And that's this one. Now this final ray, if I pick these 2 points right here, I see my slope is down 1 to the right 2. So that's a negative half x. The y-intercept is plus 2. And this is occurring if x is greater than, because it's an open circle, and it's if x is greater than 0. So this is the piecewise function for this particular graph. All right, let's look on, see what we have next. Actually, back up again. You're going to be asked some questions. So let's look at this one. They might say, instead of a y here, they might make it f of x. So go ahead and make this one an f of x. Just go ahead. I want to see that you've crossed off the y. And this is f at x. And they might say, okay, what is f at 2? Well, you have to look here. This is when x is less than or equal to negative 1. Well, 2 is larger. This is the function you use if x is greater than negative 1. So I have to use this function right here. So I put in negative, or the opposite of 2, remember this is your x, minus 3, so this answer is negative 5. So this function up here, this piecewise function, if I'm looking for f at 2, the answer would be negative 5. Or what if I'm looking for f at negative 3? Well, negative 3 is less than or equal to negative 1, so I would use this function up here. So I put in my negative 3 in place of x, plus 3 equals 0. So if x is negative 3, and you can even see it, 1, 2, 3, x is negative 3, the y is 0. So when you're given problems like this, you have to look at the conditions of the domain to see which part of the function you plug it into. All right, now let's move on. Here's a real-world problem. It says a parking garage charges $5 for each hour or fraction of an hour up to 4 hours a day. So if you're there for 2.5 hours, it's going to cost you $10 because that's part of an hour, another hour. Make a table of values and write the cost C in dollars as a piecewise function of the time T in hours and parked, and graph the function. Well, I left it up here, but I do want us to look at it. So if you're there between 0 and 1 hour, so up to an hour, we have an equal sign, that's $5. If you're there between an hour and 2 hours, so including the 2 hours, that's $10. 2 to 3, 15, 3 to 4, 20. So here's your function. These are all going to be horizontal lines. So it's going to be $5 for 0 to an hour. And this is how we're showing it. $5 is 0. It doesn't include 0 because if you're there for 0 hours, obviously you're not going to be charged. But it's a horizontal line up to 1 hour. At 1 hour, you're charged $5. So then the next part, $10. Between 1 and then including $2. So at 1 hour, you don't pay the 10, but that's where we start. And then that goes to the 2 hours, which is a closed circle. Same thing for the 2 to 3 and the 3 to 4. This is actually a special function. It says, what's the cost of parking for 2 hours and 9 minutes? Well, 2 hours and 9 minutes is including the third hour, so it's going to cost you $15. This function is called the step function because, as you can see, it sort of looks like stair steps. A step function is a piecewise function that's defined by a constant value over part of its domain. So a constant value, so it's going to be a bunch of little horizontal segments. So here, this doesn't necessarily represent anything, but it's going to, x is going to equal 1 if it's between 0 and 1. So these are all just in steps of 1. So x equals, or I'm sorry, y, f of x equals 1. So between 0 and 1. F of x equals 3, so 2, 3. If it's not including 1, but it goes to 2. And then I look at 4, so 1, 2, 3, 4, and then it's between 2, including 3. And this is going to equal 6, 1, 2, 3, 4, 5, 6. If it's not including 3, but up to exit 1, 2, 3, 4. I just want to make sure that that's right. So again, all right, here we're going to go ahead and see a piecewise function in action. You have a summer job that pays time and a half for overtime. That means that if you work more than 40 hours a week, your hourly wage for the extra hours is 1.5 times your normal rate of $7 per hour. So in part A, they want us to write a piecewise function. So we're going to look at this P in terms, so P is your weekly pay, in terms of the number of hours you worked. So it's going to be P at H equals, and we have two scenarios. You're going to earn $7 an hour if your hours are less than or equal to 40. So 40 hours, you're going to get the $7 an hour, and any hours less than that. And then you have the scenario if you work more than 40 hours. Well, if you work more than 40 hours, you're automatically going to get the $280. That's the 7 times 40. That's the $280. Plus, you're going to earn $10.50. Now, I'm getting the $10.50 because that's time and a half. 7 times 1.5 is $10.50. So you're going to earn $10.50 for every hour that's over the 40. So that's if H is greater than 40. Now you can distribute and collect the like terms if you want, but for my purposes I'm just going to leave it right as it is here. So part B, they want to know what happens if we're evaluating at P at 47. Well, we're going to look at the second scenario here because 47 is greater than 40. So we're going to take 280 plus 1050 times 47 minus 40. So that's 280 plus 1050 times 7. There's our 7 hours of overtime. So 280 plus 1050 times 7 is 7350. So you're going to earn a total of $353.50 if you work 47 hours, because you get time and a half for those extra 7 hours. And then part C, how much will you get paid if you work 30 hours? So P at 30. Well, that's less than 40. So I'll use the first one as just 7 times 30. It's straight pay. So you're going to get paid $210. So there's the rest of this. Your assignment's going to actually be a worksheet, and I will attach it to the website if you want to get started early on this.